This young lady that is standing behind me, I tremendously enjoyed talking to her, and I'm looking forward to talking to her over the next few days. She is a PhD student at the University of Reading. She is also a professional engineer and a lead AP. When I asked her what her aspirations were, she said, and I quote, "Wow, there are so many things I want to do, but you don't need to say that." Angela is new to COFES, and I've been delighted at listening to how she has been delighted by all of the things that all of us old folks have been saying through this. So with that, I would like to introduce, for your pleasure, Angela Lewis.
All right, thanks, Ken. I'm really honored to be here and really excited to learn everything I can while I'm here. And as I was preparing my presentation and had the opportunity to meet Ken over the phone, he asked me to think about and consider sharing with the audience why my research was important to me. And I came up with really three things. And the first really is that sustainability was something that was important to me and of value to me even before I knew the term sustainability existed. I spent summers with my dad and my brother some years when I was growing up taking apart various metal things. We take apart things, motors, taking the webbing off of lawn chairs, all sorts of things, and then taking them to the local scrap metal recycling facility. And during this time, I found a lot of time to think about environmental issues and really understand the impact of the things that we use on our environment. And I think that's really helped shape me as a person and shape me professionally. The other two things that really caused me to be interested in my research is just an interest in wanting to be able to do something that would be of value to the professional community and be able to invent something always sounded really exciting. And then third, I've also had just an interest in buildings. I've also found it just exciting to be able to have the opportunity to go out on construction sites, or if there's a open ceiling plenum, I like to peek my head up and see, okay, well, what can I see? What do I understand? What's going on about that building? And today I'd like to share with you the results of my PhD research through a presentation today, which I've titled "The Missing Link to Building Energy Efficiency." When I was deciding what topic I wanted to explore through my PhD research, it was really important to me to pick a topic that I felt had some practical value. So the question that really started me on this journey through the PhD was a design-build mechanical contractor had come to my PhD supervisor, who he knew quite well, and said, we install these systems in our building, and we go back a year later, such as right before the warranty period, and we find that system is not working properly. Why is this? And he felt that understanding that was really important to reaching his goals of his company. And in the specific case of the question, this was a focus on building control systems, and I've got some building control hardware as a slide there on the left. But I think this is true often for many of our systems in our buildings, our heating and cooling systems, our electrical systems. And through this question that I started exploring, I had the opportunity to conduct 3 case studies. And as I was doing those case studies, I began to see something that seemed somewhat fundamental, but was something that was missing in the industry. And I think that if we're really serious about sustainability, we need to think about what I'm sharing with you today as the missing link. And that is, we can install the most energy-efficient technology in our building, but if we don't maintain it, over time, those belts are going to start to slip, the bearings are going to need to be lubricated, and those sensors are going to drift out of calibration. So we can't just think about that system as a thing that we put in the building. We need to maintain it over time. And although this is very fundamental, if you want energy efficiency, you need to maintain it. It's something that's not supported from a process base in our own industry today. And I think this really has a large opportunity because often within sustainability we think about energy efficiency, but we don't think about maintenance. And unfortunately, maintenance is, I think it seems like a very hard thing to sell. It's very challenging. Maintenance is often seen as not a value add. But I think that this really is an interesting thing to think about, and I haven't reached a solution of how to close this loop, but it's something I definitely have a passion to think and try to work more on this area. So through my research, I identified many different challenges related to this interdependency between energy and maintenance, and I'm just going to share 2 of them with you today that helped really form the tool that I developed from my PhD research. So first, as I was doing these 3 case studies, working with 3 very different facility management teams, I began to hear this term firefighting. And before I really got into the opportunity to work with facility managers, To me, firefighting, that was, people that drive around in big red ladder trucks with hoses. But in facility management, it's a term often used, or maybe more frequently than it should be used, of how to go about your daily responsibilities. A story that I'd like to share with you briefly is I was working as a facility management consultant with a community college to help select a piece of computerized maintenance management software, a maintenance management system, to better help them do their maintenance. And I had the opportunity to sit down with 9 different facility directors and better understand what were their needs for this software. And there was one facility manager who was very eager to have me come in and chat with him, and it was really a great takeaway message, and I think provides really an extreme example of how reactive our buildings are managed from an energy and maintenance management perspective. Because within 1 hour, this gentleman had some construction going out near the baseball diamond, and someone had hit an electrical line, and he didn't have the drawings to figure out how to get that power turned off. Also, within that same hour, he had a new gym floor, but the roof of the building that was protecting that gym floor was old and leaky. He had water leaking onto that new gym floor. And, imagine trying to deal with the frustrations of, I don't have the right documentation to turn off the power. I need to keep my students on my college campus safe. Imagine having to, deal with the frustration of, we cared enough about wanting the students to have a good floor, but we didn't care enough about it to replace the roof. There was really a huge challenge he was facing. Also, when we think about reactive energy management, through the research I did a survey of some industry professionals and also just talked to as many facility managers as I could in my experience so far. And you'll find that, unfortunately, utility bills are the way that we manage our energy most frequently. Some people are going beyond utility bills and looking at sub-metering. But in general, if we think about what a utility bill is, its function is for billing. So we're getting an after-the-fact snapshot at a very high level. We don't necessarily know, maybe that utility bill was for an entire campus. We don't know what buildings were necessarily the high energy consumers, and especially we don't know what's the cooling, what's the lighting, what was really consuming that energy. Through the survey that I did after I completed my case studies, one of the really interesting things that stood out to me, because I'd worked as a mechanical HVAC design engineer for a few years, is that I asked a set of questions. First, a set of questions about maintenance, and then a set of questions about maintenance. And what I found during the survey is that I asked, are energy performance goals set during design? And you'll see here about 2/3 of the folks said, yes, we set goals. And then I was intrigued, because this is something that I didn't see in my own experience as a designer. And knowing, after I designed that super cool LEED building, did it work the way we thought? Was the energy model actually accurate? And I found that less than half of that 66% knew if their building, met those goals. And to me, that this is a challenging issue, because we think that we're providing these great high-tech energy efficient solutions, but if we don't know what challenges that the facilities team is currently dealing with if they operate the facility, we might not necessarily be doing and achieving those goals that we're hoping to achieve. And a similar challenge occurs currently with maintenance. Less than, or just over half the time, we know if our maintenance goals are set during design. And an even smaller fraction, we know if those maintenance goals have been set 1 year after operation. And just an interesting thing about these pie charts that I wanted to share too is I'd shared these with a gentleman who'd been in the industry for quite a period of time and who I respect highly. And he said, I think I agree with your data, but with most surveys, and yours included, I would say that the survey has a positive bias. So he really helped me to understand that, these chunks of yes and always and almost always are probably even smaller, and the challenge that we have in front of us might be even larger. And I guess, too, just the other point I make about that is one of the things I find really interesting with that is just this concept I like to think about that Bill East has talked about is closing this feedback loop. Is if you don't know how your building is really operated, how do you know that building that you hope to design in an energy efficient manner really was meeting the goals? So as I wrestled with all of these solutions and wanting to provide, some results that really were something actionable and practical, the last part of my research was I worked to develop this tool, and I'm really excited about this. And the results of the testing. So essentially what I did is I developed a question-driven tool that consisted of multiple choice questions about 3 specific areas: energy management of buildings, maintenance management of buildings, and then an area which I've called human factors, which is more the soft side, including training, strategy, and goal setting. And through those questions, they're linked through a set of rules, which then provides a recommendations report. And the recommendations report includes really 2 things. It includes 3 prioritized best practice recommendations of here's 3 specific things you can do to move from often very reactive to proactive practices based on your energy, your maintenance, and your human factor scores. And these one-page sheets summarize a specific best practice. I identified 35 possible ones that could be included or are included right now within the tool. And it provides a foundation that you could use either in-house to say, yes, we really want to do this, or no, this one's not quite right for our organization, or you could provide it to a consultant to say, we really need to have this done at our facility. And also, while listening to professionals I had the opportunity to interact with while developing this tool, is they found it was really important to have some kind of scale of how reactive or proactive the facility is. So the bar graph down on the left is a scale from -5 to +5 of how reactive or proactive the facility is. So the very last part of my research is, after I developed the tool, I thought, well, you know, this was exciting, but how useful or how practical is this really for anyone that developed the tool? So in the testing of the results, testing of the tool, I had 56 industry professionals participate in the testing and 38 complete an evaluation form. And I just want to share with you a snapshot of a few of the results. And 2 of the core things that I looked for in the tool was how helpful and how useful the tool was. So this slide just provides a simple bar graph of how useful the tool was. And you'll see in general, people found the tool to be useful or very useful. I don't have the bar for not at all useful because no one said it wasn't useful. Although I did have one gentleman who said, nah, I don't really see the value of this interesting exercise, but not for me, which I thought was great because it was his honest opinion. But in general, the feedback was very positive. Also, when I looked at how helpful the tool was, and also to make sure that I provided consistency of what people thought was useful and helpful, I had a short definition of what each was so that I could hope that people were looking at it from the same perspective. You'll see also that people generally found the tool to be helpful or very helpful. No one found the tool to not be helpful. And then just a few qualitative statements that I received either via email from the testing or in the evaluation form in the comments section. The first is a fee or donation could certainly be acceptable for use. The second one in green I really thought was great because to me it really meant that the person really was thinking about the function and purpose and understood the goal of the tool. And that is, the tool takes advantage of easily accessible technology to acquire, contain, and analyze information about a particular facility, thus joins colleagues to helping set priorities. And that last part about colleagues setting to set priorities, to me, I thought was great because it goes back to Keith's presentation and the question that was raised about really to move from reactive to proactive facility and building operations. We need to work together to set standards, and that will help to drive more proactive practices because we'll have a foundation to really build upon. And then the last qualitative statement is the gentleman had stated that the tool provides valuable guidance for facility management groups that utilize it. So to me, those were some pretty exciting results, and I found this research to be a really great opportunity. And I'm hoping to complete my research or graduate in December is the goal. My supervisor is currently reviewing all of my draft chapters. And at this point in someone's research and someone's PhD work, you start to get asked, so what's next? So instead of me telling you what I hope to do next, I'd like to throw the question back to the audience and say, so what's next? This tool has been really exciting for me to develop, but do you see it having any value beyond a research project? And I'd like to gather any feedback that you have. I'll be at the entire COFAS event and really eager to, hear more about your experience, lessons learned, and just really excited to be here at the event. Thank you.
Well, she asked, what's next?
So, Angela, certainly I'm glad that you thought through these things. and you've probably come up with a couple other areas that some of us are struggling with, and we'd certainly appreciate your insight as well. One is, how do you deal with those pesky occupants that get in the way of the various different facilities management practices? And then also, when we look at maintenance, how do you deal with the separations in a lot of companies regarding the budgets of, initial capital investment and operational expenses are totally separate, and you can't mix the two?
Let's see. Well, those are two complex issues, and the thing that I thought of first was Vanu, the other PhD intern who I'm sitting next to. Her research, I think, is going to be on the topic you asked, and she asked me if I can introduce you to her. So I definitely want to connect you guys, because I think you guys would be able to have a much more educated discussion on the occupants issue, because I was chatting a little bit with her, and I haven't focused specifically on occupants, but I think engaging occupants and helping them to understand their building would be one example. And the second question, I'll have to get back to you on that one because I don't have a good answer right now.
Any questions for Angela? Okay, we have a question down here with Randy.
Very interesting presentation.
Thanks.
From a lessons learned, and again, where you might go for other people who've had the same experience, I looked at this with somebody, I'm not that much of a buildings expert, but I've far more involvement and experience with industrial environments, and they have exactly the same sort of problem as far as maintenance with respect to equipment there. And again, it even applies to that question over there. How do you deal with the people, the operate? Well, how do you deal with the fact that you got people on a machine there and you're paying these people to do stuff, and yet you've got a machine that you don't know when that machine's going to break down. So when you get into predictive maintenance and all the things they do in that sort of automation environment, that again, when they started doing that process, and I don't know how many years that was ago, 10, 15, 20 years ago, they had to stop production, which was the whole basis they were there, to provide maintenance, so that they knew when to shut the thing down and do it right there and had minimal disruption for everything in their environment. It seems to me there's an awful lot of things that can be learned from those people as far as how did they get to where they are today, where predictive maintenance and all the things they do is reasonably well accepted, I think.
Yeah, no, I agree, and I have looked somewhat into the manufacturing sector. I've looked quite a bit into reliability-centered maintenance, which seeks to balance predictive maintenance, preventive maintenance, and then, reactive maintenance, because some things, you might not need your exhaust fan to be, using vibration analysis or not, but I agree. I agree.
We also need genetically modified maintenance engineers, because they need to be about 30 inches tall, generally speaking, in order to get into these facilities and do real maintenance.
Ken?
Yes? Sorry, Jack.
Tomorrow evening, during the Mayutic Parataxis presentation, which I want to point out Angela has made a great effort in supporting as part of her internship for COFES, Dick Morley is going to be giving one of the Mayutic Parataxis presentations. And Randy, if you pay attention to what he's saying in there, there's data directly related to the specific problem you mentioned about predictive monitoring and using sensors and monitoring over a vast array of sensors to understand when things are about to fail.
Okay, Jack has a question.
It's really more of an encouragement. This preventive maintenance experience is showing some tremendous return on investment. And we're now folding it forward to do preventive maintenance on the designers, which is an interesting opportunity, therefore, for the CAD software people, because right now nobody's doing that I know of is collecting information about the malfunctions of the people who are using the software.
That's a very good point. Well, I would like to again, hang on, I'll have one more question.
Thanks so much, Angela. I have a question, sort of the flip of, you're talking about using preventative maintenance to perform as well as the building was sort of designed for. One of the challenges that we're facing, we're moving into a new campus, and I'm involved in the sort of the sustainability of it. And we get a lot of feedback of, hey, that's a great idea, but it's lead gold corn shell, and we're sort of locked into a lot of the systems already, even though the interior construction has begun. So my question to you is, the flip side, are we limited by the existing building infrastructure in terms of the best that we can achieve? And what's the solution to that other than just tearing down buildings and recreating them?
Well, I think there are some limitations, but I think it really goes back to a lack of process. There was some discussion on process, and if we think about the building, there's some elements that are static, like the carpet. It's easy to see the wear of the carpet, but there's other things that are more dynamic. Our equipment, the mechanical systems, and the lighting systems, and those, if we're maintaining the equipment properly, I think we have an opportunity to make an impact even before we need to think about ripping out the equipment. Thank you.
Thank you, Angela.